Welcome, everyone. We're glad you're here tonight to join us for this webinar with Jennifer Petrich. She will be talking with us tonight about executive function and dyslexia as it relates to spelling and math. This is our second webinar with Jennifer. Her first webinar on the same topic, part one, is available to view for free on our website. This webinar is going to run about an hour and we'll be recording it. So you can expect that within the next few days, you will receive an email with a link to this recording. And in that email, there will be a link to a 3-question survey. 3 very short questions, but your feedback really helps us with our planning for future webinars, and our speakers really appreciate the feedback. We would appreciate if you just take 2 minutes to jot down a few comments when you get your link to the feedback survey. I also want to let you know that our branch hosts 5 to 6 webinars per year. Check our webpage or Facebook for events as they're scheduled. We have another webinar later this month with a group from the i2i app focusing on student advocacy. Now, the last thing we need to talk about is asking questions during this live webinar. As part of the GoToWebinar software, you should see a control panel window which will have a questions tab on it. If you click on the little triangle next to the questions tab, you should see a box where you can type your questions or comments. Jennifer will break a few times and we'll answer questions as we go and also at the end. So feel free to type in your questions in that little box. So that takes care of the logistics. We're going to begin recording this webinar, so I'll pause just a second while the recording begins, and then I will do our very brief introduction. Good evening, everyone. I am pleased to be introducing tonight's webinar from the Upper Midwest branch of the International Dyslexia Association. My name is Sarah Carlson-Walrath, and I'm a member of the Board of Directors for IDA-UMB. Our speaker tonight is Dr. Jennifer Petrich. Jennifer is highly trained in both the Orton-Gillingham approach and the structured word inquiry approach, and currently specializes in working with students who have severe phonological, working memory deficits, ADHD, and executive functioning deficits. Dr. Petrich attended graduate school at the University of Maryland, Baltimore, where she earned a PhD in neuroscience. She also has a related talk already saved onto our website, so I encourage you to check that out as well. Along with our audience this evening, I'm really looking forward to hearing your talk, Jennifer. Welcome, and thank you so much for being with us.
Thank you for that introduction. And as you mentioned, last year around this time, I did the first part of this presentation, executive function. I went really into detail about executive functioning, what it is, the neurobiology of it, how it shows up in students that I work with that have dyslexia, and how to intervene in terms of both executive functioning deficit and reading with those students. So this is kind of a continuation of that, talking about math and spelling as well. I think I'm going to review a little bit about my first talk, the stuff that I covered, because I didn't want to start, haven't seen that with nothing, but if you want more detail about all of the executive functioning things I'm going to be talking about in the beginning, you can go to that recording and watch that. And as I go along, I'll try and mention, the spots where there's more elaboration in that previous talk. Here's an overview. So this first part, the review, is going to be going through quickly the things that I talked about last time in a lot less detail this time. If you want more detail, you can go back to that talk, and how it manifests in dyslexic students. But specifically, how to address deficits when working to remediate spelling and math with dyslexic students. So we're going to talk a lot more in detail about those two issues this time. So as a review, what is executive function? It's actually a set of cognitive abilities, okay? So these abilities have to do with controlling and regulating other abilities and behaviors. So it's called the executive because it's the one in charge. This is a set of functions that are subserved by a frontal area in the brain, and it's kind of in charge of what you're going to be doing with the information that comes into your brain. So under that heading, we've got the ability to initiate behaviors, which is called task initiation, delay or prevent inappropriate responses, which is inhibition, monitor change or stop behaviors, which is the regulation part, manage interference, cognitive flexibility, and plan future behavior when faced with novel tasks and situations. So taking things that you've learned and applying them in a new situation, that's reconstitution. So I'll talk very briefly about these different abilities. And if if you know much about ADE or ADHD, some of these are similar. These are very related. I think some people are even discussing whether ADHD is kind of underneath executive functioning. But a lot of the abilities that are impaired are the same across those two conditions. And one thing to keep in mind is these skills occur on a continuum. So if you have, it's not just either or. Same with dyslexia, same with a lot of learning disabilities. It's not just you have a problem or you don't, right? That's discrete. These are on a continuum where it goes from mild to severe. And I think a lot of us on some of these functions, some of these subfunctions probably have some issues. As I was going through in the first talk, thinking about people who are always late or thinking about people who procrastinate, we all have a little bit of this. But what functions are impaired and how much they're impaired varies across people. And when you have a real high level impairment, you see a lot of times dyslexic students that have that. That's what we're talking about here. So you can divide these functions into different categories: cognitive skills versus behavioral skills. So under cognitive skills, you have things like working in memory, planning and prioritization, organization, time management, and metacognition, which is thinking about thinking. And then behaviorally, you can look at response inhibition, emotional control, sustaining your attention, initiating tasks, persisting towards a goal, and being flexible. So, and as we said, I probably said this in the other talk. So I not only work with students who have dyslexia and EF issues, and a lot of them have ADHD issues, and even sensory issues. I also have a son who fits into all those categories. So I have dealt with this both as a teacher, tutor, and as a parent. I talk a lot more about what to do at home in the first talk. This one is a lot more classroom oriented, mostly because we're going to be talking about spelling and math. But I think that it's important to realize that so many of these different functions can be impaired, but I'm going to talk specifically about certain ones that are the most important in a model that I'm going to show you in a minute. Let's just kind of review the brain and learning. So how does the brain learn things? We learn by experience, and there's a phrase, use it or lose it. So if you use certain connections in your brain, then they will get stronger, and if you don't, they will get weaker. I think people have probably heard this idea of use it or lose it, but that's really exactly what it means in terms of the connections that we make. So these are called neural networks. So you've got lots of cells in your brain, lots of different parts of your brain do different things, but you have connections, and those connections make networks. So certain parts are connected to others, and then others, and then others, and that creates a network of activation. That's really important for learning. And so this is just a little picture of some neurons that are connected. So they've got one part of the neuron has kind of these little branches that go off called dendrites, and the other part has this long tail with these little branches at the end. And they find ways to kind of meet up together, and they make connections. They don't physically touch, but they have these little things called synapses, and that's where there are chemical communications between the cells. And those neural networks are what you want to create when you're learning and encoding information. One really good way to do that is to use multisensory instruction. Now, a lot of people who are in the world of dyslexia or learning disabilities, or even just working with students, young students, a lot of times people talk about multisensory instruction. So what is that? It's using all of your senses, right? So we've got sensory, which is what's coming in through your senses. So it can be touch, and usually when you're talking about, they'll say tactile, that's usually touch, right? And motor, so it can be the senses coming in, and it can be motor, which is movement, right? So you can, your body can encode things, they call it motor memory. A lot of times in sports, you practice enough, you kind of develop this motor memory. And then auditory, obviously things that you're listening to, and visual things that you're seeing. So you want to use all of these modalities when you're teaching, because then you're getting networks that are going across different brain areas, and they're using lots of different types of information and networks being activated together to encode the information. So people talk about, are you a auditory learner? Are you a visual learner? Are you a kinesthetic learner, which is usually has to do with the motor part of it? And people may have one strength, more strength in one area than another, but in general, if you hit all of them, everyone learns better that way. So we want to keep that in mind as we go through and talk about some of the things we're going to talk about later in the talk. So just basics about the brain areas. So we've got, I don't know if you can see my cursor, hopefully you can. So if you see auditory, it points to this area on the side of the brain. This is looking at the left side of the brain. The left side of your screen is the front. The right side of your screen is the back. Underneath you have the cerebellum. And so we're basically looking at the left side of someone's brain. So the auditory is where that arrow is pointing, that kind of middle area. Visuals in the back. Sensory and motor, so your tactile and your kinesthetic are up on top. You have these integration areas. So you've got these, what they call primary sensory areas. So information's coming in your ears, your eyes, your sense of touch, movement, and those have to be integrated. So we have these areas that take that information and integrate it. Then you have to decide what you're going to do with that information. That's where your EF skills kind of come in. So you've got all this information coming into the brain, and then part of the brain has to be responsible for going, what is coming in, and how do I process it, and how do I decide what I'm going to do? Then you have motor planning, and you have motor output. So motor planning is when your brain is planning for your response. The very top that says motor, that's a strip that comes down. That's a lot of the body motor, but then also next to it in this frontal area also is the speaking part. So if you're going to talk, if you're going to say something, you need to plan those motor patterns as well. So we've got sensory information coming into the different parts of the brain. They get integrated, they get processed. The EF, the executive function, the executive part of the brain decides what you're going to do and how you're going to respond, and then you have the plans that have to get executed. So the foundation of EF is when the information's coming in, you need inhibition. That's important because you don't want to just react to things, you want to process them first. And you'll see, like I said, a little crossover between ADHD and EF. A big problem with kids who have kids that have ADHD have is inhibiting responses, right? They have a problem with impulse control and inhibition. So that's the first kind of stage. Then you've got working memory. What's going on? How are you going to process it? Well, you have to hold the information in order to manipulate it. That's working memory. So you can have verbal working memory, which is language information coming in. You got to hold on to that and be able to manipulate that and process that. You also have what they call nonverbal working memory. The interesting thing is that a lot of people talk about nonverbal working memory as being impaired when it could actually be a language processing issue. If there's not enough language processing working memory capacity, you can actually have trouble in the nonverbal working memory domains. And that's because in order to be able to manipulate information of a nonverbal nature, we tend to attach language to it. And if you don't have language to attach to it, then it's a lot harder to hold on to that information, even though it's not of a verbal nature. And then we've got the shifting and cognitive flexibility. So if we're working on something and more information comes in, or there are distractions, we have to make sure that we can keep focus and go towards the goal, or change directions if we need to, depending on the new information that's come in. So that's this idea of shifting and cognitive flexibility. So those are all foundational functions. And here's a model. So it's called the hybrid model. It's a pretty well-known model in terms of EF and ADHD. But like I said, you've got this behavioral inhibition. What are we going to do with this information once it comes in? I have to hold it in my working memory. I have to regulate affect, motivation, arousal, make sure that my emotions are in check and my attention and focus are in check, and that I'm regulating that according to what I need to be able to do. You've got this internalization of speech. And that's going to end up being the key piece that we're going to talk about as we move through talking about students with dyslexia and then into what we're going to do about spelling and math, especially math. So we've got to work on this piece because that tends to be what's really impaired in the dyslexic students. And then reconstitution, which I said in the beginning, has to do with we've got information that we've learned, we've got a new situation, how we're going to use what we know and apply it in this novel situation. And after all of that is done, and we've done all of that processing, then we have some kind of output, right? So motor control, fluency, syntax. So that has to do with some kind of behavioral movement response or some kind of verbal spoken response. And that there can be a breakdown in many different areas in there, but the one we're specifically going to talk about today is this internalization of speech piece. Now, unfortunately, when it comes to executive functioning, I find that there are lots of accommodations, not very many people talking about what to do to remediate it. So some of the accommodations you might see, which are helpful and necessary, are using step-by-step instructions, breaking things down into pieces for the student. Written directions with oral instructions whenever possible. Again, that's that multisensory, but also if they've got some kind of language processing or phonological working memory issue, talking to them and just giving them oral instructions is not enough. They need to have written directions as well, and even having them verbalize. So you've got oral instructions means something's coming in. If they're not processing it and doing something with it, then you don't know what they've gotten from what's come in. So that's why it's helpful to have the written directions there for them to refer to if they need them, but also to have them verbalize, because then they're having to process the information in a totally different way than just listening. So we also want to use visual organizational aids, visual schedules, alarms, things like that. A lot of that has to do with the time management, task initiation. If it's something that they have a really hard time with regulating internally, then they can use external cues of a visual nature to help them. I think that in all of the students I've worked with and my son and things that I've read, I think that a lot of it is there's the language processing piece, but there's also the activity in the brain piece. And it seems like there's just so much activity going on in the brain that sometimes the signals that we would normally get to check in about something or to think about how long something has taken or how long you've been doing something, they're so lost in what's going on in their brain that they don't have that. So it's nice to have these external aids or cues. And then planning, structuring transition times and shifts and activities so that, we've got, okay, we don't just shift gears, 0 to 60 in 2 seconds. We go, okay, we're going to start winding this down and then we're going to start gearing this up. So giving them time to be able to shift from one thing to another. So that's general accommodations. A lot of times I see those in IEPs for classrooms, but that's not going to help you kind of fix what's going on. So let's talk a little bit more about what's going on in the students that have dyslexia and what we're going to do about it in terms of helping remediate it and then how to apply it to other domains like spelling and math. The key, like I said in that one model, is the internal language, right? So this also called self-talk, internal speech. I've seen it called lots of different things, but this idea that you've got language information going on inside your head, essentially. In students that have dyslexia, many of those students have poor phonological processing or poor phonological working memory or both. And so when you've got that issue, that internal language often just doesn't exist or it's severely impaired. And I think people don't even realize how much they use this internal language in their head when they're doing things, especially when you're learning something new. And so for these students, you may not even realize that they don't have it. What you end up seeing is often family members will step in for these students when they need to speak about something. So because they have this language processing issue, they tend to be slower to process language, slower to produce language. So let's say you've got a 6-year-old and you ask the 6-year-old, so, what is your favorite subject in school? They may be taking time to process that question or to process and prepare their response. But meanwhile, people are sitting and waiting for the answer. So a lot of times a parent or a sibling or even a friend might step in and answer for that student. So what ends up happening is you get this dynamic where they're not practicing verbalizing externally. So not only do they have this impairment, they don't get to practice fixing it because somebody's always talking for them. So one of the first things I have to do when I start working with a student that has EF issues and has this language processing issue is to train the family not to step in for them. So you're going to end up having to have them verbalize externally a lot before the internal takes over. What ends up happening often for these students is what I call islands of knowledge. So typically, like I said, you've got information coming in. So whether you've seen it, read it, heard it, this information's coming in and you want to encode it. And often it's verbalizing it out loud, it's writing, taking notes, things like that. But it's storing the information via some other modality, but also a lot of talking to yourself about it is what happens. And by doing all of those things, you're creating those networks, right? So you're taking these different parts of the brain and you're creating activity in these different parts. There's a phrase, the neurons that fire together wire together. So if you're activating these different areas at the same time, they're going to have a stronger connection. For students that don't have those other pieces and they don't have that internal language, they hear something, some of it sticks, some of it doesn't. They often have trouble with writing, so they're not taking notes. They often have this impairment with responding and verbalizing, so they aren't given a chance to verbalize. They're not raising their hand to answer things. They're not given a chance to explain their understanding of something. So they just have like whatever happens to stick from listening. I remember reading a stat recently that if you listen to an hour-long lecture within 36 hours, you do nothing else, you just sit and listen. Within 36 hours, you've forgotten 90% of what you heard. And that's for typical people. So then you take somebody that has this language processing impairment, and how much are they holding on to? Now, there's repetition. So in school, they might hear or see the same things over and over again. But again, if they're not doing anything with that information and it's just coming in, you just get these random pieces of information that aren't connected to each other, that aren't connected. You don't have a concept and language and an image or a picture all attached together. You don't have that. So you just get these like little pieces, something there and a little piece of something there. So that is kind of what ends up happening to these students when they're trying to learn something. And you need this internal language. You need it for following multi-step directions. I just tried to give examples. So like a recipe, learning new motor tasks. So if you're learning to tie a shoe or you're learning to swim, when you're doing those motor tasks, you might need language to help you remember what you're supposed to do. And like I said, I think we all do this and don't even realize we're doing it. I really, in working with students, I've seen this, but I also remember in first learning a few different signs. So the next one I have is copying visual-motor input, right? So writing letters or signing a sign in sign language. If you are looking at something and you're trying to copy it, sometimes it's very difficult to get your brain to tell your hand what to do. So you have to use language to do it. So say for teaching kids the letters in handwriting, a lot of times there's little dots where you're supposed to start and there's these little arrows, but you actually have to say to yourself, okay, I'm going to start here and I'm going to draw a circle and then I'm going to draw a line down. And a lot of kids will do that automatically in their head, but some won't. And then it just becomes, I'm not breaking it down into steps. I'm just trying to make this picture match this picture. And then they may not have a very consistent way of making the letter. So they might do it different ways, different times. And then it's not being associated with all the other information that's supposed to go with that letter. Sign language, like I said, I remember a couple times. So one of the signs was China. And the sign for China is this. And for some reason, as I'm watching that sign, I couldn't copy it. I don't know why, but I just had a mental block. And I had to say to myself, Okay, so when you sign, you use your dominant hand. So I just say, okay, go to the non-dominant side, go across and down. And that helped me do it because I couldn't copy it as I was watching it. So we use language to mediate these behaviors all the time without realizing that we do it until it becomes automatic. And like I said, establishing these neural networks of activation. So kind of like a domino effect, right? You activate this, which is connected to this, and then all down the line, you activate that network. So I tried to think of some examples. So one would be like New York City. If I say New York City, what kinds of things pop into your mind? You might get pictures of the city. You might hear the Big Apple, or you might see the words the Big Apple. Most people have some kinds of associations that are all connected. And when you hear one thing or see one thing, then you activate those other connected things. Right triangle, another example. I have lots of middle school, some high school students, and it's amazing when you say to them, tell me what you associate with a right triangle. They can't tell you anything. Sometimes they may even say they're not sure what it is. Then maybe you draw a right triangle and you put the little square in the corner and they're like, oh, I know what that is. And then maybe they can kind of remember some of it, but they don't know what to call anything. But you start showing them things and they can recognize it, but they can't recall it because it's like I said, those islands of knowledge. There's a little bit of stuff in there, but they can't access it because it's not attached to any language. It's not attached to anything that they can access and recall with. It's only recognition. And also they don't know what things are called. I'm going to talk more about that when we get to the math piece. But because that vocab doesn't stick, they probably have to hear, I think I remember hearing 10 times. It's funny, 10 times pops up a lot. When your kids are real little, they say you should let them try some food 10 times before you decide they don't like it because it's just new and different. They might need exposure. But I also think that's with words 10 times. You have to hear a new word 10 times or use it 10 times. For a lot of these students, it's going to take even more repetition before it's encoded. And so a lot of times they might hear new vocabulary and it doesn't get processed or it doesn't get encoded and then it doesn't get attached. And so even if they know what the, of course now I'm having anomia, right? Even if they know what the Pythagorean equation or Pythagorean theorem, even if they don't know what that is, they might know it, but they have no language or no name attached to it. So the a squared plus b squared equals c squared, if any of you remember your right triangle information in math, a lot of people remember that equation, but they don't know what it's called. And it's really hard to access something that's abstract like that, especially if you don't have an image of it either. If you write a squared plus b squared equals c squared a lot, and you know it's the Pythagorean theorem, and you write that, it's going to all get encoded together much more effectively than just listening. So we're going to talk through a lot of what we're going to do to help remediate that. So one thing you can do is increase phonological working memory. So if students cannot hold on to very much phonological, meaning just language, verbal, if they can't hold on to phonological information very well and manipulate it, that might be something worth working on. A lot of people probably don't know how to do that, so you might want to make sure you have someone who knows how to work on phonological working memory. I think that people's understanding of what phonological processing, phonological working memory is not quite accurate, and it's been dominated by phonics. So really what happens is you've got phonological processing skills that some kids start out with. Early would be like rhyming or being able to add sounds or take sounds away from spoken words. A lot of kids can do that early on, some kids can't. The ones who can will then start reading, and the more they read, the more their phonological processing, the more they start developing this idea of phonemes and how those attach to graphemes. And so it's not just letter symbol, but it's these ideas of what are the speech sounds that matter and how do we spell them. That impacts the way that your brain is set up. So reading actually, it's not that you have what they call phonemic awareness, which is not a great term, but it's not that you have that and then you learn how to read. It's you have a good ability to segment and and process phonological information, and that gets you started on the reading. And then once you keep reading and writing, then you keep going, and your ability to make those connections improves. What happens with dyslexic students is often they don't have this phonological foundational piece, whether their working memory is not good enough for them to hold on to more than 2 or 3 sounds at a time, or they can't do the rhyming and the manipulation, the taking the sounds off, putting them back on. And so then they don't start down that road, and they get kind of stuck. And by the time that gets remediated enough that they can really start reading, often they've missed years of print exposure. And then they don't want to read. That's a huge obstacle, especially with my middle school kids. So you do have to kind of work on some of those foundational pieces and make sure that they can rhyme, they can play with the sounds in words. And you may have to do something that's explicit and concrete with manipulatives for them to be able to start holding on to more sounds and playing with more sounds, to help with that phonological working memory piece. That is something kind of separate that needs to be done, and that's important, but not the only thing and not the most important thing you need to work on. The next thing is practicing verbalizing, right? If you practice verbalizing a lot of that phonological processing and working memory will also get better. So even if you don't explicitly work on that piece, you can still help them develop that by verbalizing. And like I said, a lot of these students don't talk a lot when they're younger. And so there's oral motor feedback that you get from talking, and there's encoding that happens when you talk. And so that piece isn't happening either, just like the reading piece isn't happening, that verbalizing piece isn't happening. So you definitely want to have them practice verbalizing externally. The key, though, is since they are not good at doing that, you have to model it for them and help them get from copying to doing on their own externally and then doing it on their own internally. So it's a process. I work on it explicitly with my students, but you can do it while you're doing anything. So this idea that modeling, I'm going to say and I'm going to do just to show you. So like I said before, break things down into steps. So I could take something that I want a student to do and I could break it into steps. I could say each step and I could do each step, and they could see how I broke it up and how I was doing it. Then we could do it together. So we say what we're going to do and then we do it. Then you can do instructions. So I say and you do. But in parentheses, you'll see I have with verbalizing. So the idea is I say it, and then you do it. And then you can flip, you say, and I do. So I'm going to say, I'm going to do whatever you're telling me to do. Then the student has to say it and do it externally and then internally. So if I were learning how to tie a shoe, I might break it down into the different steps and say what I'm going to do. I'm going to take my 2 laces, make an X, and pull one through and pull it tight. And going through each step like that. It's things that we do and we don't even realize it, because I find that a lot of people have trouble even breaking things down into these steps because they're so automatic. But if you can model that, then you can do it together with them, then they can copy it and they can learn how to do it on externally and then internally. And you can practice that process in anything that you're doing until they can start to do it on their own. So like I said, you could practice with physical tasks like shoe tying. You could practice it with imagery tasks, getting ready in the morning. That's something that I think that a lot of these students have trouble with. And when you're a parent of a child like this, it gets kind of frustrating in the mornings getting ready for school. But you could sit down and say, okay, what are the things that we need to do in the morning? Let's get a picture in our head of the steps that we're going to do. And if they have trouble, you can kind of walk them through it, but then have them think about the imagery, imagine what they're going to do, and then have verbalize it. I also often, this is something I might add signs to. It's something that for a long time, we had kind of checklists on the wall. I'm sure a lot of people who have ADHD kids and executive functioning impaired kids have some kind of visual concrete cue. Drawing on paper. So again, you could break something down into steps, especially letters. It's a really good thing to do, practicing your letters. Okay, so first I'm going to put my pencil on the middle line. Then I'm going to draw a circle and come back to my starting point, you know, and so you're talking through the steps, then you're going to do it with the student, then you're going to tell them what to do and they verbalize it and do it, vice versa, and follow all of those steps. Again, using it with other modalities to store information. So we want to have the language, the pictures, the gestures, the concepts, so that all of it gets encoded together into those networks. And problem solving and encoding new information. You definitely want to not just take the information in, but you want them to be able to process it and do something with it. So write it down, say it out loud, draw a picture, do something with the information so that you're tying other things together in that network. So let's stop for a second and just see if anybody has any questions about the basics of executive function that I just went through.
I think we're good for now, Jennifer, so let's keep going.
Okay. Thanks. So let's look at spelling. So I'm going to throw some things in here. This is not, if you've heard of SWI, this is not how to do SWI, but I'm talking about it because it's a process I use with my students, and I think it's really important when you're trying to work on spelling to know some of this information. If you want to know more about SWI and scientific investigation of words and spelling, there's lots of resources out there, and I can add it to the end of the slideshow when it goes up on the website. But this idea that there's a long history of spoken English, that we had Old English, Middle English, present day English, and it's been around for, let's see, Old English started in the 400s. So we've got this really long history of spoken English, and everyone likes to talk about how crazy English spelling is, right? But if you look at the history of spoken English, it's not crazy, and you understand where the different influences came from and why we have Latin and Greek influences, why we have French influences, why we say English is a Germanic language, where all of these things came from. You also want to understand writing systems are based on meaning, not speech, right? So there are all kinds of writing systems in the world, and they're on a continuum. Some of them are very transparent, like Spanish, right? So you kind of more or less have one sound, one letter, and this correspondence. On the other end of the spectrum, you have Chinese, which are pictures that have nothing to do with the spoken language. In both of those situations, words and the writing system are actually based on meaning. Speaking is, I have something in my head and I want you to understand it. So I speak it and it goes in your ears and you understand it. Writing is, I've got something in my head and I want you to understand it. So I'm going to write it and you're going to look at it and understand what I mean. Is there an association in English between the sounds and the letters? Yes, but the choices we make for spelling are not based on speech, they're based on meaning. We have homophones for a reason. The homophone principle tells us that if two words mean something different, they're going to be spelled differently, even if they sound the same, if at all possible. So as much as people hate homophones, the interesting thing is they're spelled differently for a reason, so that when you look at them, you know what they mean. And it's not something you can sound out because they sound the same. And it's not something to memorize, it's something to understand. And when you investigate the meaning and how the writing system works, all of a sudden you understand why one is spelled one way and one is spelled another way. There's also elements and suffixing conventions that students need to understand. How are words built? What are the pieces that you put together? When we add suffixes, what kind of changes do we have to make? And the scientific investigation, I put SWI process. So in the introduction that I had sent, it says approach, and I'm still not 100% sure how to talk about that to people because it's not a program for sure. And it's almost not even an approach. It's really a process. It's a bunch of questions that you go through to investigate words. All of this is important because if you're going to investigate the writing system properly and you're going to use this process, it's steps that you have to follow. So if you do these steps with typical learners, then you show them and then they do it and it's not a big deal. But if you're working with students that have EF issues, then you're going to have to help them figure out how to do this process. So we're going to have to go through it the same way that we do any of these other processes, where we identify the steps, we model, we practice together, we verbalize, all of those things. So just to go quickly through the process, we look at meaning, we look at morphology, which is the form, how it's built. We test a hypothesis about the structure. We can look at the etymology, which is the history of the word. We can look at orthographic phonology. So how are we spelling the sounds in this word? And then if we have to revise our hypothesis, we can. So the 4 questions that we need to ask: what does it mean? How is it built? What are its relatives? And what parts of pronunciation are important for meaning? We will model this process, verbalize what we're thinking when we're doing it, the questions that we need to ask ourselves, and then you can also use signs or gestures to help students remember the 4 questions if they can't hold on to them. So for sign language, this is meaning, how is it built? This is building. Relatives, this is connection or relationship, relatives. Pronunciation, this is saying words, pronouncing words. You can use other gestures. I tend to like using the signs because I know them, but you want to have some way for them to hold on to it. And you also want them to be able to verbalize it back to you. You want them to be able to write them down. All of those are those multiple modalities, encoding everything together. It's the same every process that you use. And eventually abstract yourself out of the process, which means I've modeled it, we've done it together, you've stored it in lots of different ways. Now you're going to do it on your own. And you can use visual cues if you need them. If they need a little card that says what the 4 questions are, then that's what they use. The idea is this is a really important process that they need to learn. And so you want to walk them through it so that they can get them independent in being able to do it. So just to show you how this works really quickly for a word, and again, like I said, if you want to do SWI as a process, there's lots of information out there on the internet for learning how to do it. But the idea is, if you're using it, how do you get your students to implement it independently? So your different questions, what does it mean? How is it built? The history and the relatives, and what can we learn from the pronunciation? So a good word that people like to talk about with this scientific inquiry is sign. People usually think that's a good example because it's something you have to memorize because the G is not pronounced. Or people might say the GN spells N. Well, how do you know that? So let's look at what it means. There's actually a lot of meanings to sign. Maybe you haven't thought about all the different meanings, but we've got a noun, object, quality, or event whose presence or occurrence. This definition is pretty funny to me, but occurrence in the probable presence or occurrence of something else. So a sign that something is going to happen, right? Then there's gesture or action used to convey information or instruction, like sign language. And then what's going on in math, you have the positive or negative sign. You have a verb, you have signing someone's name, like your signature, and then also the verb to sign. Okay, how is it built? Are there pieces that we can take off? Do we see any pieces that are attached? No, SIGN is just a base element that we could build on with other prefixes and suffixes. History, how old is the word? Where did it come from? If you look, you'll see it came from Old French. Like I said, there's French influences and Latin influences and Greek influences. So you go back and you see it was Old French, sign or mark from Latin, signum, which is important. Looks a lot like ours, but has this little piece on the end. That's a Latin suffix. Okay, here's the verb. Originally, to make the sign of the cross is what it meant. Go through, you see in the italics, those are all the foreign words. So if you go down to the middle in italics, you see that signum again, that's the Latin piece. Okay, so what are its relatives? So what are other words that have that SIGN piece and have a related meaning, but have other things attached to it? So we've got sign, signing, signal, signify, design, designate, signature, resignation. A lot of them probably things you never even realized are related. When you go through and look at the structure of each of these, you learn a lot about these other pieces, but you also start to understand maybe why the G is there. I even had a student figure out, they said, well, every time we add, if you look at like signal and signify and designate, when you add a vowel after that N, all of a sudden that G gets pronounced. Is it really a GN spelling N, or is the G just pronounced sometimes and not others? This is called a matrix. This is one of the things, if you're going to do SWI and investigate words scientifically, something you can put together. All this is all of this information put into a matrix. So we've got prefixes we could add here, we've got suffixes we could add here, and then we could practice building the words, and we would know how to spell them because we just need to know which pieces we're putting together. And the more that you do this, and the more that you practice it, and the more that you write it and say it out loud and verbalize it, the better encoded it is. And it's not just memorizing, it's understanding, and it's doing something with the information so that it's now created a network of activation. So then the question, if we go back to the very beginning, why is that G there? Well, it was there in Latin and it was pronounced in Latin, signum. We removed that, we lost that Latin suffix. And in the pronunciation through French, the G stopped being pronounced, but not always, right? So in sign, that G is not being pronounced. In design, that G is not being pronounced, but in signal, it sure is. And in resignation, it sure is. So when we look at the pronunciation and we look at what is being spelled by each of these letters, we find out that that G is there because it has to be. It's pronounced in a lot of the different words that have S-I-G-N. It's just not pronounced in the, it's not pronounced when it's a base or when it's at the end, right? Like a design doesn't have the G. So that's something that we can learn, that that G sometimes is not pronounced, but has to be there because the words in the family that are related in meaning need it because that G is pronounced there. So here's just some other things to ponder that we usually have kids either memorize or tell them English is just crazy, right? So why is there a W in two? If you think about all the other words that are related to two, you have twice and twin and 20 and 12 and between and twilight. They all have a W because they all have a tw. The W is being pronounced, right? If you look at the history of the word in Old English, it had a TW and it was pronounced. Now we don't pronounce it. Why don't we? Spoken English evolves and changes over time. That word is a very old word, and so we don't pronounce the W anymore. But why do we keep it? Well, because in that family of words that are all related in meaning, that W marks that relationship to all those other words where it still is pronounced, and it was pronounced. And if we took that W out, TO is already a word. TOO is already a word. TOE is already a word. Any other way you could think of spelling too is already a word, right? So we want to spell it differently, so we keep the W. Different. What's going on with different? Well, we have what they call a zero schwa, right? So we don't spell it like this because it comes from the word differ. Here's the word differ, and it's got an ENT on the end. So if you understand the meaning of the word and its relatives, all of a sudden these letters that we don't pronounce, it becomes obvious why it has to be there. And the E in change, why don't we get rid of it? That has to do with the pronunciation and the fact that this G is a J, and if we put an A after it, we don't usually spell a J with an A after it, so we keep the E. So when we study all of these different questions and investigate through this process, you learn all kinds of reasons and understand why words are spelled the way that they're spelled. So when you do that, that is really helpful for these kids who, A, have trouble holding on to verbal information anyway, and B, have trouble memorizing things, especially when it's just of a verbal nature. So now you've got them following a process, you're modeling the steps, you're having them verbalize the steps, you're having them write things down, announce the spellings, encoding all of this information so it's not just memorizing, and that they really understand the word and why it's spelled the way that it's spelled. Okay, so now let's go into math. So what I want to kind of get across is the same things that I've been talking about. So we've got the idea that we want to have language and concepts and visual information and maybe motor information, write things down, verbalize, and connect all of that together. In math, there are so many different topics you could do this with, but I kind of went through quickly what some of the basic ones are and things that I run into my students having trouble with, right? So number sense, operations and math facts. Again, math facts. How do we do math facts? You memorize them. What do these kids have trouble with? Memorizing. Operations, it's amazing. You think it's addition, subtraction, multiplication, division, easy. I can't tell you how many of my students with EF issues and dyslexia can't even tell you the names of the operations. It's not being encoded. Word problems, of course, all dyslexic students I've ever had hate word problems, even if they get math, just because it's hard for them to take the language information and turn it into math. Fractions, so many people hate fractions, and decimals and percents go along with fractions. And algebra, it's interesting. I find that most kids who are either algebra kids or geometry kids. But one thing I found with algebra for sure, even if they have an abstract understanding from sitting and listening and watching in math class, there's just these random pieces of information. Nothing's connected. There's no language attached to it. So we're going to walk through and talk about what you want to do for them so that they can anchor this information and understand it and hold on to it and access it. Okay, so quickly with number sense. So in math, it's always good to go from concrete to imagery. So you want to have something visual, something concrete, some kind of manipulative that they can see and interact with, that multimodality, right, learning, and then work towards imaging that in their head. So using manipulatives, looking at number lines, playing with the numbers on number lines, and even using ASL numbers can be helpful. So the numbers in ASL, so it's all one-handed. So 1, 2, 3, 4, 5, and then you turn it around 6, 7, 8, 9, 10. It's helpful, and then I guess we could do to 20. So 11, 12, and 13, 14, 15, 16, 17, 18, 19, 20. So you can see even in ASL, there's a relationship between the single digits and the teens, right? So there's some way to mark them that they have the single digit, but they also have that 10 piece added. So that's kind of a conceptual thing that becomes a little bit obvious when you sign the ASL numbers. And then what do you want to do with that information? You want to give it labels, you want to investigate those labels, and you want to practice verbalizing. So what is a number? What does it mean to count? Where do those words come from? People might think cardinal and ordinal. You're never going to get kids to remember that. But you will if you study them and you look at how they're built and you look at what is the base. Are there prefixes or suffixes? Where do they come from? Ordinal, we have this idea of order. Most kids know what it means to put something in order, even if they're still learning that with numbers, this idea of putting something in order. Magnitude, where does that word come from? What does that mean? Let's study that word. Adding all of that information together and having the students use it and verbalize it and understand it makes a huge difference in their ability to understand number sense. Operations and math facts, same idea, concrete to imagery, right? So you've got manipulatives to represent what you're doing with the different operations. You've got symbols, and you can use signs and gestures. So there's not only the symbols have signs, right? But there's also signs for adding and for total and for subtracting. So if you add those, it's amazing when I watch my students that have this EF issue and this language processing issue, and they have trouble naming the operations. If you add signs or gestures or whatever you want to add to it to add that motor piece, it's amazing how they will end up remembering that piece very easily and then using that to access the language. So they might be able to go like this and say subtract or subtraction. So they can't pull up the language, but when they attach something to it and they do it, they can. And then again, investigate and verbalize, right? So practice saying addition, subtraction, multiplication, division, adding the gestures or the signs that you're using, talking about the symbols, writing the words, writing the symbols, and investigating where these words come from. If you notice, they all have the same suffix. They all have an ION at the end. Some of them have prefixes in front. Some of them have different, pieces that are the bases. But when you study the words and you understand where they come from, and you connect all of these pieces together, then you end up getting this idea conceptually of what they mean, but you also have the labels to attach to it and the symbols so that when you need to access the information, it's there. And then also using what you know to figure out what you don't know. This is a huge thing for math facts. I find that people are so big on memorizing, but really, if you know some of your math facts, you can always use that to find out other ones, especially if you have visual cues, right? So if you have, say, a number line and you want to do multiples of 3 because you want to know the 3 times tables, you could mark on the number line 3, 6, 9, 12, 15, 18. They could get a good image of that in their head. You could practice having them image it in their head. You could sign the numbers and you could have them practice doing that. You could have them write the list. You could have them say the list. There's so many different pieces that you can add to this to help them encode all of that information. What ends up happening is, let's say maybe they know 3, 6, 9 really well. They know 30 and maybe they know 15. If they get used to seeing them on a number line or in a list and understanding how the whole thing works, then when you have to do 3 times 9, you don't have to go 3, 6, 9, 12, 15, 8. You go, well, I know 3 times 10, that's 30. If I go back 1, that's 27. It's very difficult for kids to do that in just language alone. But if they have the image of a number line and they know and they've seen where all of these multiples are, and they've practiced and they've written and they've signed, then they know they just have to go back 1 to have 3 nines instead, 9 threes instead of 10 threes. And then once they realize they can use what they know to figure out what they don't know, it's not just about memorizing and always having to start at the beginning. They can now manipulate and hold on to things and access them in a way that they couldn't when they just had to memorize just from language alone. Okay, so oops, I'll try and go through. There's only a couple more slides. Word problems, again, students with dyslexia, big problem, word problems. Part of it is reading, so they are reading and they have to take that language, process it, and figure out how to turn that into math equations or math information, math representations. That's part of it. But also, they have to understand the operations conceptually to be able to read something and know what operation to do. So a lot of the kids that I get that are having trouble in math, when it comes to word problems, they never even understood the operations in the first place. They don't have labels for them. They don't remember what they're called. They're not sure which symbol goes with which. And then they're supposed to read a word problem and know which one to do. So again, concrete to imagery. So you can have manipulatives and you can practice with addition or with subtraction, with multiplication, looking at word problems, modeling how to think about it and what they're going to do with the manipulatives. And you could attach signs. You could have them write down information and then using that conceptual concrete into imagery, like we talked about with the other ones. And the idea of let's look at it, let's read it, let's figure out what we know, what we want to know, and how we're going to figure it out. So with the operations, one thing that I've done a lot is, again, using signs to talk about conceptually what the operations are about. So when I think about addition, subtraction, multiplication, division, what do they have in common with each other? What's different about them? So addition and multiplication, what's the same about them? It's about putting things together. I start with pieces and I put them together to make a whole. This is the sign for together or with. And all of my students learn this and they know addition and multiplication. If I've got subtraction and division, I'm starting with a whole and I'm taking things apart. That helps in a word problem. I read a word problem and I say, okay, am I starting with pieces or am I starting with a total? Because that already tells you you've got 2 choices, depending on which one you have. Then how is addition and subtraction different from multiplication and division? So if I know it's a together and I'm putting things together, so I've got addition or multiplication, how do I know which one I use? What is multiplication? How is it related to addition? A lot of people have never even thought about that. But if you think about multiplication, it's just a shortcut for addition. Addition is I've got 2 pieces and I want to put them together and make a total. Multiplication is I have a lot of pieces, but guess what? They're all the same. And so if I know my multiplication facts, then it's a shortcut. I don't have to add 5 plus 5 plus 5 plus 5 plus 5 plus 5. I can say, oh, it's 6 5s. I know what that is. It's just a shortcut. So then that way they can look at the problem and say, well, I'm putting things together, but am I taking two different pieces and putting it together? Or am I taking a lot of the same piece and putting all of that together? Same with subtraction and division. Am I starting with a total? Am I taking a piece off, which is subtraction? Or am I dividing it into pieces that are the same size, right? So that's conceptually what you need to understand. That's how to use signs. You could use manipulatives and show them the same thing, have them practice, model, verbalize, all those same pieces. You want to do that with every single thing that you're doing, so they get practice doing that. Fractions, decimals, and percents. So same thing, concrete to imagery, right? So I've got something, I'm dividing it up into pieces. I can use manipulatives. I can talk about the symbols and the signs. I can investigate and verbalize the words. Fraction, right? What is a fraction? Does it look like anything we've seen before? Do we see any pieces that we can take off? We see the same ION that we had in addition, subtraction, multiplication, and division. If you take off that IN, what is FRACT? That's not a word that we've ever seen before. Are there other words that have FRACT? Fracture. A lot of kids know what a fracture is. What's a fracture? It's something that gets broken, right? So what's a fraction? It's just breaking something into pieces. And I sometimes do signs when I don't even realize it, but so we use that a lot, right? So we're breaking into pieces. So that's one way you could talk about fractions. You could talk about the symbol for division. I don't know if anybody's ever noticed, but the symbol for division is a line, and you've got a dot on the top and the bottom. Looks a lot like a fraction, which is really what we can represent with fractions. We can represent division. They're kind of the same idea. And then decimals and percents, you just work off of fractions, but you can look up decimals. What kind of pieces do you see in decimals? Does it look like anything you've seen before? Is there a relationship or relatives that you know? Percent, same thing. Percent in the word tells you what it is. Per 100. Percent is just how many out of 100. And it says it right in the word. So again, it's this understanding. It's spelling out the word after you investigate the pieces, writing it, verbalizing it, connecting it to manipulatives, to imagery, and tying all of those pieces together. Algebra, it's huge because there's conceptual understanding, which I see a lot of my dyslexic kids actually kind of have this weird conceptual abstract understanding of some of the things in algebra, but they have no way to talk about it. They have no vocab, they have no language associated with it. It's very hard to store, and it's extremely hard to access this information and to follow steps to solve problems if you don't have any of that information associated with it. You haven't created those networks. So what can you do? You can investigate and verbalize. When you say evaluate the expression, what does that mean? Well, let's look at the word evaluate. It means to give it a value. What is the word expression? Most of the students that are doing algebra, they know the word expression or express, what it means to express, right? And so it's this idea that you've taken a concept or words and turned it into a math expression, right? You've expressed it in math terms, and you just need to evaluate it. You need to give it a value. Isolate the variable. If you're trying to solve algebra equations, usually what you want to do is isolate the variable. Most of them don't know what a variable is. Maybe they've heard the word, maybe they don't remember hearing the word. I'm sure they did hear it, but it didn't stick, and they don't know what it means. I love the sign for this because if you look at variable and you think about, okay, where did it come from? How is it built? Built off of the word vary, right? Your Y changes to an I, so you get to talk about spelling rules, suffixing conventions. You see the ABLE, VARY, what does that mean? It means something that can change. And the sign is like this, something varies, it goes up and down. Super easy to associate all that information together, and now they have a label for it and they can access it. What does isolate mean? Again, you can investigate. Solve the equation. I can't tell you, I've done a lot of algebra lately, I guess because I have some older middle and early high school students right now. An equation, they don't even know what it is. But you look at the word equation, again, what's at the end? ION, take that off. What do you have? Well, you had an E that you took off, it's equate. It means to equate things. They usually know what that means. And equal, it has the same piece, that EQU, and it means that you're taking two things and you're setting them equal to each other. This is the sign for equal. So now we not only know what an equation is, but what happens if you put an IN and an ITY at the end? You get inequality. So when kids start doing inequalities in algebra, they can't explain it to you. They can't tell you what an inequality is. All it means literally is not equal. So if you have to solve an equation, it just means it has an equal sign in it, and the two things are equal. It also helps them understand why you have to do, if you do something to one side of an equation, you have to do it to the other, because they've got to be equal. If I do something to one side, I've got to do it to the other side, or else they're not equal. Plotting ordered pairs when you get to linear equations. Why is it called an ordered pair? Most people have never even thought about it before. It's a pair because it's two things and it's ordered. It matters which one is X and which one is Y, right? And there you see that ORD in order, just like the ORD in ordinal, way back in number sense. Linear, same thing. Where does it come from? It's related to line. Plotting linear equations. You say linear equations, and a lot of them have no idea what you're talking about. You write y equals mx plus b, and they're kind of like, oh yeah, I've seen that before. But they don't know it's called a linear equation because it's not stored, and it's not, and even if they've heard it, they're not able to access it because it's not all stored together. So just quickly, here's like if we wanted to walk through subtraction. Conceptually, what is it? Talk about whole versus the parts. We're starting with the whole thing and we're taking it apart. Here's the sign, you take away the part, right? And what's left, you're either going to look at the part that was taken away or you're going to look at what's left. Let's investigate it. We know there's an ION. A lot of kids know an SUB. If they don't, and you look it up and you look at the history of the word and you look at where it comes from, you'll see that there's an SUB in the front. And then you have this TRACT. Well, what the heck is that? Well, tract is a word, like a digestive tract. Most students aren't going to know that word. But if you look up that word and where it comes from, it's actually a form of this Latin verb, which means to pull or draw. So subtract literally means to take away or draw from below. You can draw pictures, you can use gestures, and you can verbalize the steps. So again, thinking about the concepts, thinking about the relationships, investigating, verbalizing, drawing, gestures, all of it over and over and over again with everything that they do. And then you can solve an example problem so they can get used to doing both the procedure as well as understanding the concept. So a quick summary. For executive function, we've got this idea that we've got input coming in. We have to inhibit so that we can process and determine our output. Okay, so it's the basic idea of what's going on. You want to always break down larger concepts into smaller pieces or steps. You want to model the language and the thought processes, right? So it's really important to have the students verbalize, and you want to all have them verbalize out loud first. Eventually, they'll start internalizing that language. You want them to be able to use resources if they need them, usually visual in nature, but you also want to have them store information in multiple modalities so that you can anchor the concepts and the language not only together, but to other things. Like I said, imagery, pictures, drawing. I mean, it's a picture's worth 1,000 words. Like, it's amazing to think about how true that is, especially when you're talking about like math or science. You draw something and label it, there's so much information they can store just from that picture. It makes me go back and think about my schooling and things I hated doing, but I realize why. It makes a huge difference when you add all of those pieces together. And then of course, practice, 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 right? So you want to be good at anything, you have to practice. So with dyslexic students, like I said, I often see them after they've had some kind of intervention that hasn't worked, or years of intervention that hasn't worked. I get them often in middle school or high school. And there's psychological pieces that go with getting help that late. And a lot of times they don't want to read, and they don't want to write, and they don't want to talk. So we start slowly, but the idea is if you want to get better at it, you have to practice. So having them practice verbalizing as much as possible, practice writing as much as possible, practice reading. If you've got to, give them the the cues or the resources, or if you have to do it with them, take turns, model, do whatever you have to do to get them to practice, because that's going to anchor the information and encode it and make sure that they can access it once they learn it. Okay, I'm going to add some resources to this because this is the EF resources, but I think I want to add the SWI resources too, so that people, if they're interested, can go out there and learn some more about how to use that with dyslexic students and EF impaired students. So that is that.
That is great, Jennifer. I'm looking at, I think that was a ton of information, very, very helpful. I don't see any outstanding questions.
Okay.
All of that. So I guess we will just remind folks that in a few days they will receive an email with a link to this recording, and also your slides will go along with that. And then you mentioned you were going to add a few more bits of information to the end of that, so people can look forward to reviewing those when they receive them in their email. Do you have any parting words, Jennifer, before we sign off?
I was just trying to figure out how to get me back. Everyone sees my screen. How do I?
We can.
It's fine. I was just trying to. I had a video thing before, and now I don't have that, so that's fine. They can see my messy desktop. And one thing I meant to say in the beginning that I forgot is I want a lot of this to plant seeds for further learning and further investigation. So the things I repeated 1,000 times are the things I want people to go out and do, right? So so modeling and having kids verbalize and having kids anchor language and concepts together, but specifically for the SWI or for the math, doing a little bit more learning, a little bit more thinking and studying. This is just a starting off point, like a jumping off point, right? So I didn't want this to be kind of, SWI in 5 minutes, but more this idea that it's out there. It's extremely helpful and useful, and hopefully it's a starting point for a lot of people to go out and learn more information. And also that, I come from a science background, and so I worry sometimes that people will see something or hear something or watch a video of a talk and think, that's it. What they said is 100% accurate and will always be accurate. But it's funny that, everything is about our current understanding. So it's our current understanding of how the brain works right now, or current understanding of these models of how executive functioning works. And so again, just thinking about, what you know about something, and not just saying, oh, well, I saw this, or I read this, or I heard this, and going, well, that is something that I've heard before. Let me learn more about it, and let me read more about it. I think is just a really good approach to take when you're taking these, watching webinars, listening to people do workshops, presentations, things like that.
Absolutely, that's great. That's great advice as we end the webinar. We appreciate your time. We appreciate all the attendees online. We invite everyone to visit our website, and you'll find a library of all of our recorded webinars and registration information for upcoming webinars. Thanks everyone for being here, and have a great night.
Thanks.
Thank you.